Good morning, everyone. Today I will teach you with mathematical equations step by step. For this topic for today, it is addition, subtraction, multiplication, and division of radicals. So first, I am going to teach you the addition of radical. And by this given example, for your POV, I know it looks so hard, but when I teach you step by step, it will be so easy. So let's do the first part. 18, fifth root of 243. In this given here, we're just going to copy 18, and we will determine what is the fifth root of 243. You may think that that index is kind of big, so you might think it's possible, or possibly 2, 3, or 4. So first, let's see. Let's divide this into 5. Now, we will try 2. Let's see if it's correct. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32, which is not correct. We didn't find the fifth root of 243 with 2, so it's not 2. No. Now let's try 3. 3, 3, 3. There. And we will multiply by each. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3, which gives 243. Right, it is 243. So we found the fifth root of 243, which is 3. So we will simply put multiplication dot here and then put 3. We will times it because we got the fifth root of 243. Next, copy the 31. And then we have to find the seventh root of 128. What are the possible factors? I mean, the index is big again, so it's either 2 or 3. That will be the answer. Let's see. So let's try 2. Okay, so 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. Oh yeah, it is 128. So the seventh root of 128 is 2. Let's put the multiplication dot here and put 2 since we found the seventh root of 128. Next, we copy the 7 over here, we see. So next, we have to find the sixth root of 64. Let's make it 6. Perfect. Now, since the index is big again, you might think that it's either 2 or 3. Yeah. So let's try 2. Because you have a feeling that it might be 2. So let's see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. Yeah, we found the sixth root of 64, which is 2 again. Let's put the multiplication dot here, and then we put the 2 outside the radical sign since we already found the sixth root of 64. Next, last part, which is we copy 15. And then the radicand is now bigger. Like, you can imagine. Well, let's think clearly. We have to find the fourth root of 625. But since you found the 5, you might be thinking it's divisible by 5. But let's see if that kind of works. So 5 times 5 is 25. 25 times 5 is 125. And then 125 times 5 is, let's solve it. Oh yeah, it is 625. So the answer for the fourth root of 625 is 5, since it's divisible by 5. Okay, since we all got the possible answers, we shall combine similar terms. So 18 times 3 will be, okay wait, 18 times 3. Let's try. It is 54. Yeah, let's put 54 here. Oops, let's put 54. Then 31 times 2, that gives us 62. Yeah. Okay, next. 7 times 2, which is easy, which is 14. And then lastly, 15 times 5, which will be 75. Now, we shall combine similar terms again because we can see a lot of combining similar terms. So let's do this. 62 plus 54 is 116. Then 14 plus 75 will be 89. Next, we will finally solve it in the true answer. So 116 plus 89. Simple math, you know. Alright, so the answer for 18, fifth root of 243, plus 31, seventh root of 128, plus 7, sixth root of 64, plus 15, fourth root of 625 will be 205. That is how simple it is. That is how simple it is to add. And yeah, step by step. Next, I will explain the subtraction of radicals. In your POV again, I know it looks so hard again, but each step I make will make more simpler. So let's start for the first step. 9 cube root of 729. So we need to find the factors of 729 by cube root. So in this case, since the radicand is quite big and the index is kind of smaller, like, you get it. So it's either 8, 9, or 10. So first we are going to try the 9 one, since it's kind of divisible by 9 over the third digit. So yeah, 9 times 9 times 9. So 9 times 9 is obviously 81, and 81 times 9 will be 729. Oh, it looks like we found the cube root of 729. Yet again, you shall copy the 9 over here and then put the multiplication dot. Since you found the cube root of 729, you no longer have to use the radical sign. So it's 9. Next, 3 cube root of 3. What do you think is the cube root of 3? Well, there's literally no factors of 3 cube root. So either way, you just have to copy it. It's not 1 though. Next, 5 fourth root of 9. In this third part, we can find the factors of 9, which is 3, right? Yeah, but it says here, in the index, it's 4. So all we have to do is do this step. Okay, let's do this step first. Let's copy the 5 here and let's do the step of the fourth root of 9. I will teach you, so don't worry. So in this given over here, we are going to turn that into like this. What is the square root of 9? 3. So we'll simply put 3 but with a square on it, because we will do something that is quite kind of complicated, but don't worry. So next, you just have to turn this into, the exponent will be the fraction. Remember, over here will be the numerator, while the index shall be the denominator. So 2 over 4. Next, we can simplify or divide by 2 since we found it. So the answer will be 3 raised to the 1/2. And then you're going to turn this into with a radical sign again, which is this. Why is it like this? And why did you not put the 1 and 2? So basically, over here is already like, if it's a square root, the 2 should be invisible, while the other things like 3, 4, 5 is not invisible. So if you put 2 here, it's okay, but if you put none, it's also equivalent to 2. And why didn't I put 1 over here? Because it's just 1. So it's the square root of 3. That is how it works. Now we will put the square root of 3 over here. Next, for the fourth part, 19 cube root of 3. So over here, there's literally no cube root of 3, so you just have to copy it again. Next, 10 square root of 9. So while I said earlier, there's always, if it's invisible, you will call it square root because there's an invisible 2. So what is the square root of 9? 3. So we will simply put 3, like that. And then next, it's time to simplify more. 9 times 9 is obviously 81. So next, for this part, let's see the matching or like similar terms. So over here we got this, and then you found another this. So you just have to put them over here, and then you will combine similar terms. We will do that, and then we copy the negative 5 and square root of 3 because it got no, like, combining similar terms. It doesn't have a partner, so we say it like that. Then next one is 10 times 3 is obviously negative 30 since it's negative. So we found another combining similar terms, which is 81 and 30. So I will put this over here. There. Next, let's combine similar terms. 81 minus 30 is 51. Then put a minus sign because it's negative. Next. Oh wait. Yeah. Okay, so you will see negative 3 cube root of 3 minus 19 cube root of 3. We don't minus the radical nor the index. We combine negative 3 and negative 19. According to the law of integers, negative plus negative is equals negative. And we can add them up, but the answer will be negative. So 19 minus 3, or negative 3 plus negative 19, rather. It will be 21. And then copy the cube root of 3. Next, we copy the negative 5 square root of 3. Since it got no partner, so we will not combine similar terms. And now for the final result, this is the true answer. That is how you do 9 cube root of 729 minus 3 cube root of 3 minus 5 fourth root of 9 minus 19 cube root of 3 and minus 10 square root of 9. And the answer will be 51 minus 21 cube root of 3 and minus 5 square root of 3. Next will be the multiplication of radical. In this given example, let's try to solve it, but it's multiplication. Have you ever heard of FOIL method? Here's the formula for FOIL method. It's like that, and then this one will be the opposite sign, and then it's equals to like that. That is the formula of FOIL method. And we will do exact like this given example. Square root of 5 minus 2 square root of 2, then square root of 2 plus square root of 5. First, let's put the F, that stands for first, O stands for outside, I stands for inside, and L stands for last, which is called the FOIL method. So, first, you will do this, the F1. The square root of 5 times square root of 2. Then, for the outside, it's 5 again to another square root of 5 in the end, the first and last, so that's why it's called outside. So, square root of 5, then multiplied by this square root of 5. Next, inside, the inside will be here, the negative 2, square root of 2, and square root of 2. So, let's put it here. Like that. And then the last will be this one, the negative 2 square root of 2 again, and this last again. So let's put negative 2 again with square root of 2 multiplied by this one. That is how FOIL method works. Or you already have heard of FOIL method. It will make the progress easier. So each step I make, I hope you understand. Now let's try to multiply it. Square root of 5 times square root of 2, which is square root of 10. Next, square root of 5 times square root of 5, which will be 25. But since it's square root of 25, there's an actual factor of that, and the answer will be 5. Let's put 5 there. Next, this negative 2 square root of 2 times square root of 2. We will only do the radical because it only says here. So the answer will be negative 2. We will copy the negative 2 and then square root of 4. But there's a factor of 4. So what is the square root of 4? 2. So negative 2 times 2 is negative 4. So the answer for here will be negative 4. Lastly, which is the last, negative 2 square root of 2 times square root of 5. So yet again, it's always a radical. Negative 2, and then multiply them together will give this. There is no factors of 10 that can give a perfect square, so that is how it works. Then, let's put all of them here. So, square root of 10 plus 5, negative 4, and negative 2 square root of 10. So, for the last, we will combine similar like terms. So 5 minus 4 is definitely the same. And then square root of 10 and negative 2 square root of 10 is that we can combine 2 because it is also 10. So first, let's do the square root. Negative 10 plus negative 2 square root of 10. By combining this, there's always an invisible 1 over here. So 1 minus 2 will be equals to negative 1. But since 1 is always invisible, the answer should be like this. Like that. Negative square root of 10. Let's put it here. Negative. Oh my god. Negative. There. Perfect. Now, this is the most easy part. 5 minus 4, which is obviously 1. Then, it's time to merge them together. The answer will be 10. Negative square root of 10 plus 1. That will be the answer for the square root of 5 minus 2 square root of 2. Then, square root of 2 plus square root of 5. The answer will be negative square root of 10 plus 1. Lastly, we shall do the last type of radical, which is the division of radicals. So in this given here, it says square root of 2 plus square root of 5 divided by square root of 5 minus square root of 2, almost likely to be known negative square root of 2. In this given example, we shall multiply it by the fraction, like we copy the denominator but with different signs. So this shall be square root of 5 plus square root of 2, and then copy again square root of 5 plus square root of 2. It should be like this, but with different signs according to the denominator. And then you shall multiply them separately. So we will use parentheses to help us, I guess. Yeah. Then in the numerator, it looks like we are going to use in exponential form since they both kind of look the same. So we shall turn this into square root of 2 plus square root of 5 with a squared outside the parenthesis. Then we should use this denominator, which is most likely to be different. So we shall use this formula, which is called like this. A minus B, then A plus B is equals to A squared minus B squared. It should be supposedly like that. So let's try. Yeah. So after that, we'll make this into 5 minus 2. Since we use the formula parent, A minus B multiplied by A plus B is equals to A squared minus B squared. Then, after that, we can use the formula A squared plus, let's do it over here. A squared plus 2AB plus B squared. Ang tinutukoy ko about sa numerator, okay? Since it's squared. So, let's try with the given formula. Okay, like that. Okay, that should be done. Okay, next. Okay, let's like that. The A will be square root of 2 and the B1 will be the square root of 5. So, A should be the square root of 2 with a square in it. Then for the B, I forgot. There. For the B, it should be, square root of 5 over there. And then we copy 2 since the formula is stated over there. So then let's put the square root of 2 and square root of 5. After that, let's combine. So, square root of 2 raised to the exponent of 2, which is square root of 4. But then, we just found the factors of 4. Since it's square root, what is the square root of 4? Easy, 2. So, we simply put 2. Then for this, let's combine the radicands. So, square root of 2 times square root of 5 will be square root of 10. And then we copy the outside of the radical sign. There, perfect. Then, what is square root of 5 raised to the power of 2? So, that will be 25, right? 5 times 5 is 25. So, then there's a square root of 25, which is 5. Simple as it is. So, the answer should be like this. Yes. Then let's put it over here. Hold on. Okay. Let's minus this first since we can combine similar terms. So what is 5 minus 2? 5 minus 2 is 3. So let's put 3 over here. And then, so since we got that numerator, the answer which is this, let's put it in this numerator. Then, we found actually a combining similar terms. Can you guess what it is? Of course, it's 2 plus 5 over there. So, we shall combine these. 2 plus 5 will be 7 plus 2. Square root of 10 over 3. We cannot combine the 7 and 2 because since 2 is connected to the radical with the radical sign. So this shall be the final answer. Thank you so much for listening and I hope you enjoyed. Subscribe to my channel to find more mathematical equations step-by-step videos. Thank you so much. Goodbye.